Hi, everyone. I gave a talk at the Epigenetic Inheritance Symposium in Zurich, Switzerland yesterday, and I neglected to record it. So what I'm doing right now is just taking my script and re-recording it pretty much the same as I presented it yesterday, and you'll just have to pardon the artifice here, but it is the same content. Okay, so here I go. Hello, everyone. Thanks to Dr. Isabel Mansui for this opportunity to present on the missing heritability of autism and whether epigenetic inheritance may be playing a role. Please note I'm a bit unusual here. I am not a researcher, but instead I'm a research advocate and philanthropist. I'm based in California and I'm involved in many autism organizations. But most importantly, I'm the mother of 2 children with profound nonverbal autism. Jonathan is 26 and Sophie is 19. And Sophie is in fact here with me in Zurich, but not here with me right now. My role is not to find answers, but instead to focus on the other side of the scientific method. I'm a hypothesis hunter who develops new ideas, but then advocates for scientists to do the actual investigations. So while I have no pretenses about having answers, I also think there is an important role for the development of new hypotheses, particularly in the field of autism. There has been a lot of debate about whether autism rates are truly rising or whether the growing numbers are merely an artifact of diagnostic and awareness shifts. But the reality is there really should be no debate here. The evidence for a true increase is overwhelming and can't be explained away by social factors. For example, in my home state of California, we see an exponential increase in the autism caseload over the past 3 decades. And these cases are limited, the cases I'm showing here from the developmental services system, are limited to those with substantial developmental disability. Those with high-functioning autism are largely excluded from this system, yet we see a 70-fold increase. And while this shows caseload over time, the birth year prevalence trend is very similar where we have that data. Meanwhile, the other forms of developmental disability in this system have flatlined. That's like intellectual disability, CP, epilepsy, and those have not decreased. That can't explain the skyrocketing rates we see in my state. Now, from a national level, the CDC has detected similar trends in autism prevalence, which you see on the left. Even when limited to more severe cases, which you see on the right here in yellow, defined as cases with intellectual disability and ASD, we see a 3-fold increase just in 14 years of surveillance. Over the past 3 decades, much money and much effort has been expended on finding the causes of autism and this mysteriously increasing prevalence with very little to show for it. There are 2 major paradigms. The environmental approach has investigated exposures to the mother and fetus and the infant as well. But this line of inquiry has come up almost empty, with some exceptions like very preterm birth of the child, some maternal infections, and some drugs like valproate acid or sodium valproate, which is an anticonvulsant drug. The other approach, and the one that has received the lion's share of funding and attention, is genetics. Genetics is a popular hypothesis mainly because autism has been shown to be highly heritable. There is high concordance among twins and high recurrence among siblings, like you see in my own family, having 2 children with severe nonverbal autism. But this heritability has emphatically not been explained by genes. Clinically speaking, only about 10% of cases are explained by genetics, and maybe 20% if the cohort is limited to more severe types of cases. Pardon me, got to change my page here. Oh my gosh. Okay, moving on. So is there another way to contemplate the missing heritability of autism? I stumbled onto one such idea way back in 2012 when I serendipitously discovered that I had been very heavily exposed in utero to synthetic steroid hormone drugs that were given to my mother for the ostensible prevention of miscarriage. This was 1965, and my mother had gone to a cutting-edge fertility clinic, and she was given steady and heavy doses of these synthetic hormone drugs. Now, knowing that these compounds, these synthetic hormones, together with the hormone receptors, could act as transcription factors, I wondered how they may have influenced the molecular development, not just of my body and my brain, but also of my nascent oocytes. So I began talking with experts, but I also began surveying parents. I've talked to about 350 of them over the years, either in person or through surveys, about their own histories of exposures and also their partners' histories as well. And I stumbled onto something very unexpected and something that jumped out at me and grabbed me by the throat, something that was not on my radar at all. And this family here is a great illustration of this phenomenon that I seem to see. Here, you see their oldest daughter suffers from a rare de novo GRIN1 mutation. She is profoundly disabled, and she has extremely minimal functioning. The youngest, a son, has idiopathic profound nonverbal autism, and the middle daughter is a neurotypical girl and very sassy. Most people would look at this family and wonder, why did lightning strike twice? But unlike most people, and certainly unlike pretty much every clinician in the world, I looked at the mom and immediately had questions. I noticed a divot above her eye socket, and then talking to her, I found out that she had undergone 7 successive surgeries for a brain tumor and facial reconstruction, all before having children. Now, by the time I met her last year, I was entirely unsurprised to learn this, because I had noticed this sort of pattern in so many other autism families. Here is just a snapshot of such families, almost all of whom live near me and all of whom are personal friends. I did not have to cherry pick or go to the ends of the earth to find these patterns. In yellow, we see 3 young adults with profound idiopathic autism. In these cases, all the fathers had multiple successive surgeries, about 5 to 7 of them. 2 of these were a result of the father suffering accidental gunshot wounds. The other was for a father who had various medical issues and accidents. In pink, we see 2 sets of brothers. They're not twins with profound idiopathic autism. And it turned out their mothers both had lengthy 8 to 9 hour surgeries in their adolescence for a burst appendix. In green, we again see families with sons with idiopathic autism, and these moms had 2 or more very early life surgeries, including at just 2 or 3 days old. In orange, this young lady is the daughter of a friend who had a typical child. Then she had to have abdominal surgery to remove a 12-inch inflamed appendix. Then shortly afterwards conceived this daughter who has idiopathic profound autism. In blue, we see 2 brothers of 2 moms. All the boys have idiopathic autism, all 4 of them. The moms both had endometrial and other surgeries before conceiving their boys. Finally, the friend here in purple in the corner, this is a story that initially led me down this hypothesis pathway. This mom has twin girls with idiopathic autism. Her own mother had her appendix removed when my friend was just 7 months gestation. So she was exposed to surgery under general anesthesia as a fetus. So all of this information, of course, I'm just showing you a tiny, tiny piece of it here. And reading of the literature and speaking with researchers led me to a very unconventional hypothesis of autism. That a parent's, it could be a mother or it could be a father's history of procedures under general anesthesia, or at least modern general anesthesia, is associated with molecular germline risks. And these may in turn disrupt offspring neurodevelopment. Okay, hold on, turning the page again, which seems to be a problem today. Okay. Now, of course, this hypothesis comes with a bunch of caveats. If it's true, and of course we don't know if it's true yet, it's likely a rare effect with very low absolute risk. Otherwise, like all of our kids would have autism, because pretty much everybody has some exposure to general anesthesia. But now it's just it's 3.2% of kids. In addition, you have what's likely 7% more with ADHD, yada yada. But still, it's not 100% of kids. But potentially, despite there being probably a low absolute risk, there's potentially a very high population risk because of the prevalence of these types of procedures and exposures. So maybe what we're seeing are risks related to very prolonged exposures to general anesthesia, repeated and successive exposures, or very early life exposures. Also, my methods were very casual. I didn't have a control group at all, except for sometimes asking about the parents' unexposed siblings and their children. There's a huge risk of confirmation bias here. I was really looking for certain patterns after a certain point. And of course, I'm simplifying what's going on here because life is messy, exposures are messy, and there may be a lot of other things involved that I didn't even ask about. But at the same time, there are many indications that we should be taking this idea very seriously. First is the timing of the introduction of the modern era agents of general anesthesia. Use of the more potent halogenated inhalational anesthetics accelerated in the 1980s and early 1990s, which is around the time we see this inflection points of increasing rates. Incidentally, these compounds are used at higher concentrations in young children, which I think is a very important point. The IV, the intravenous anesthetic propofol, came along in the late 1980s, again coinciding with the uptick in rates. I highlight sevoflurane and propofol because these are the two most commonly used in the United States. Second, these compounds are toxic at multiple levels. I can't go into all the details now, but you can look up more details. I'm happy to share my slides with anybody. They are neurotoxic. They alter receptor binding and shift the excitatory-inhibitory balance. They're genotoxic. They're epigenotoxic. They're immunotoxic. They are reprotoxic, and they are ecotoxic as well. These are hardly benign chemicals. Third, and really most importantly, the animal studies looking at this question have all witnessed heritable effects of these drugs. This was actually first observed in the 1980s, but only re-examined 34 years later, first in the lab of Anatoly Martinyuk at the University of Florida. 2 other labs have also conducted such experiments, including Victor Corses, who has presented at this conference. In summary, and these were all sevoflurane studies, they found that in F2, so that's the offspring of the exposed parents, they found dysregulation of brain development and or the evidence of autism-related behavioral traits, all with a strong male bias when that was investigated. And of course, the strong male bias is clearly seen in autism with something like a 3-to-1 or 4-to-1 sex ratio, male to female. Now, these effects seem to be due to abnormal transcription factor binding in the germ cells or other forms of epigenetic misprogramming in the exposed germ cells. And as for the mechanisms that cause this, it could be related to direct effects or indirect effects via strong hormone dysregulation, inflammation, and or other means. Such as, for example, folate depletion. I mean, we can go on. Fourth, human sperm studies also provide some support for this idea. We've known for a very long time that general anesthesia affects general sperm parameters. So the health of sperm generally is impaired by general anesthesia. For some reason, with the declining fertility and declining sperm counts, general anesthesia hasn't really come up as a potential culprit. But that's aside, that's a little tangential issue that I think really warrants investigation. Significantly, and Romain Barres spoke on this study at this very conference some years ago, surgery, in the case of his study, bariatric surgery, was associated with significantly altered DNA methylation in the sperm. They looked at DNA methylation before surgery, shortly after surgery, about a week after, and then 1 year following, and they found dramatic changes in DNA methylation in the sperm following the surgery. Now, Dr. Barres would attribute that to the changes in nutrition after bariatric surgery, but Dr. Martinyuk and I have both written that we think that it's much more likely due to the effects of surgery itself under general anesthesia. Also, several studies have looked at the sperm of autism fathers, and though these studies did not inquire about paternal exposures, they found abnormalities in DNA methylation of sperm, and another study found high rates of sperm mosaicism in autism fathers. Also, it's well known that age of father does have a positive correlation to autism risk. So aging sperm, for example, might not be able to repair itself as well as younger sperm, and therefore it might confer a greater risk on the offspring. Fifth, I would also just suggest that human epidemiological studies are consistent with this hypothesis, although I note that to date there have been really no studies directly on this topic. But there are many robust findings of links generally between the F1 parental medical history, which is often associated with surgery and general anesthesia, and F2, that is their children, ASD or neurodevelopmental disorders. This includes parental and family medical history, where children of parents with the highest level of medical conditions, they are at sharply higher risk for autism than those with parents with very low histories of having medical treatments and conditions. Parental preterm birth, which is strongly associated with a need for anesthesia for various life-saving procedures, is associated with their child's autism risk. Parents' infertility disorders were strongly associated with F2 autism risk. Although I note that in this very intriguing study, which I think came from the SEED study in the US, they looked at a small number of fertility-related surgeries, about 34, and saw no increased risk for F2 ASD, although there's very little detail about this, and it's such a small number, and these are so poorly characterized, I really don't know if that's enough to make us really question this hypothesis. Again, I'm thinking there's a low absolute risk. We'll need a big N to really robustly investigate it. Preconception maternal opioid use, again, often associated with medical and surgical history, is associated with F2 ASD risk. Maternal abortion history is also associated with F2 ASD. Parental traumatic brain injury is associated. And in one study, and I helped fund it, we looked at, or I didn't conduct the study, of course, but I helped fund it, that maternal childhood surgery under older forms of general anesthesia, and we were looking mostly at, surgeries in the 1930s through the 50s, is associated with no school or special school for their offspring. That study had very limited endpoints. I'm not sure how much we can draw in terms of conclusions from it, but that was a very interesting finding. Finally, I note that while I've focused on surgery and general anesthesia in this talk, we might be concerned about other exposures as well. Some F1 exposures linked to F2 autism or other neurodevelopmental disorders include paternal chemotherapy, maternal, and that's via the gestating grandmother, diethylstilbestrol or DES. This was a synthetic estrogen that was given to really millions of pregnant women, and it was carcinogenic, and it caused various impairments in the children and now the grandchildren as well. Really a horrific period of medical history. Maternal occupational solvent exposure, which is super interesting. Grandmaternal tobacco use in pregnancy. Paternal tobacco use, at least in this one study from Korea, but other studies have been negative. And interestingly, based on this new study, probably not paternal use of sodium valproate, that anti-seizure medication. It's an HDAC inhibitor, therefore it's an epigenetic drug, but they didn't find a link to ASD when that drug was used around the time of conception, according to this new study. Okay, moving on, almost done. Summary and observations. Autism prevalence has grown immensely over the past 35 years. We so far have failed to identify the causes with some minor exceptions. The sources of this missing heritability of autism, and in addition, the early dysregulation of brain-related genes, and also the mysterious male bias, these are the central questions in autism research today. Some answers, I contend, might be found in the realm of anesthesia exposures to the F1 parental germline, whether it be the sperm or the egg or their precursors, way back to this primordial germ cells that form in embryogenesis. Although other exposures may be of concern. But here, of course, I focused on anesthetic drugs. Research in epigenetic inheritance, unfortunately, tends to ignore novel, high-dose, direct, and intentional exposures like general anesthesia. We need more research on these powerful toxicants. But this, while it's an important direction for research, it's currently really a black hole in the field of toxicology. Finally, we need more focused research on toxicant germline interactions in all the fields: epidemiology, animal models, human sperm, oocytes and their precursors, and where it may be, and also in vitro studies. Although I do have to say that studying oocytes can be very, very difficult, and I acknowledge that that's fraught with much more difficulty than studying sperm. And I just finally want to thank all the parents who shared their family histories with me, and all the researchers who have encouraged me along the way and given me ideas along the way, and who are investigating these important and novel questions. Here is where to reach me. I'm happy to answer any questions you might have. Thank you very much.